All right, this is the discussion for group 3. Read group 3.
Yeah, group
All right,
3.
so let's let number 1 take it away.
All right, so for the first question, we've got this board with some force couples on it, and we are specifically trying to solve for the diameter of these 4 pegs on the, I don't know if you can really see it, but
Here, do you want to bring the board a little
Yeah.
closer? I like that.
There's these pegs on the corners of the plank or whatever,
Not to scale.
not to scale. And we are also given a moment of 1142.5 pounds inches in the counterclockwise direction. And so our idea of what to do with this is to set it up using the moment equals force times perpendicular distance. We use that equation. And you can set this moment equal to the sum of 2 perpendicular forces, or well, they're perpendicular moments. So you could use this one, which is completely in the, I consider this the I direction. And so you could set that one up, but keep in mind that we're solving for the radius, so you have to add in the radius of this peg and this peg. You could also just do one diameter, but
Yeah,
for some reason my intuition was to use radius.
I think that makes more sense a little conceptually.
Yeah.
Because like you're looking at it from like, yeah, I see what you're talking about.
But yeah, you could totally just skip that part and use diameter. And then to add to that, you would take a perpendicular one and then just do the exact same thing. And from there you have your R, which is your only variable, and you have one equation, so you can just solve for it. And then at the end I got this radius and I multiplied by 2. But like I was saying earlier, you could just skip that entirely if you just use diameter at the start.
Yeah. And then, so it looks like on this equation, this part originally threw me off, is like you have 2 components. But like technically you're solving, we do have 4, right? So we have 4 tensions. But the reason it appears to be 2 is because like, on the normal ones, like this is your R from here to here. But then it's like this portion and this portion. So then those together, that's why it kind of looks like only 2 components. So it's like this. Yeah, I don't know if that was a good explanation, but that kind of confused me until you were able to like. So it looks like it's only 2 components, but there is all 4 accounted for. But yeah. All right, number 2.
Like that.
You see it? A little closer. This is beautiful.
Hi, I'm Rowan. This is number 2. So we're given this system with like this triangular kind of system with 2 force couples, F1 pointing down and up here, and I think I forgot to draw F2.
Oh, the F2s are right here.
Wait, yeah, where's F2? Oh, F2's, yeah, right here and right here. So it's F2, yeah. So we have 2 force couples and they want us to make it into one. So first I saw that the distance between B and C, or between F1 is B and C. So I want the vector BC, which we get, and the distance between F2 is BE, so I get the vector BE too. To get the height for E, actually, we can see that the cross section of this triangle, it's like similar triangles. So if we know the length of this like outer triangle here, which is 20 and 10, we can just say that it's similar.
Oh, so it kind of like scales down.
Yeah. We get 2 values here, we only have 1 value here, but since they're similar, it's just like it gets scaled down by a factor of 2. So after we have our force values, or force vectors, and our R vectors, we can just cross them and get our moments. So this moment is for F1. So this is, M1. And this is M2. And we get the M2 using our R vectors, and you kind of have to use cosine and sine. Given our size, we get the angle to find the force components. But after we get both of them, we can just add it up to get the resultant moment. And taking the magnitude of that, we get 1,009 pound inches. And to get the angles, we just use the same formula we've been using, which is theta n is the inverse cosine of that force n over force. And you get 75, 40.75, and 127.
Okay, so I noticed you used like so your magnitude or your moment was 1009, and then you were using negative right here.
Oh,
what was
yeah.
what was the reasoning for that?
So at first I did positive, but I was getting the wrong answers. But I realized that this is just the magnitude, so this is positive. But since we have negative x and y values, it's like a negative magnitude.
Oh, so like if you look at it like put it onto the like form.
Intuitively.
Yeah, that's a good word.
Like
yeah.
in the reference frame of our XYZ plane, it would actually be pointing away in the
so that
negative
it
direction.
becomes negative.
So if you use the
okay.
negative directions, you get the right angles.
Oh, okay. Yeah, that makes
Yeah,
sense.
yeah.
Intuitive. That's the word of the day. Word of the week.
Intuitive.
Good job, Thomas.
Thank you.
All right.
All right, number.
Good job, guys.
Thank you.
Is this? Oh no.
this
Wait,
is-
okay.
We got 3 and 4 on this board. It's a little two-parter. I'm Thomas Brandt. So for this one, we essentially want to find the magnitude ultimately. We're not going to worry about moment for this first part. Just the magnitude of the FYFX total. So this is what we're given. This one's pretty straightforward. We did need to use a little trig here. So we're given this angle, and then we're given this this force that's coming in at an angle, which we need to find its components. So we'll find f of y, f of x. It's pretty straightforward. And then next we have to find the net y forces and the net x forces. So not only is it from this component, but we need to remember the given forces were also given. And eventually, now we have a net y and a net x, and so we'll use that to find, basically the magnitude between the two is going to be the hypotenuse. So we're going to use
Good old
Pythagorean
Pythagoras.
theorem. Yeah. And then you'll eventually get the answer of hopefully 29.866 pounds. For number 4, we eventually want to solve for ry, rx, and we're given this moment.
So that the given moment is this right here, right?
Yeah. I think so. Yeah, right there. So 85 pounds inches, and first I wanted to calculate the. Yeah. So ultimately, we want the net moment, but to find that first, we need to find out other moments from the other forces. So we're gonna rearrange this equation that we know and love. It's m is equal to r cross f.
I mean, I really like R cross F.
Yeah, language, please. So we'll get r is equal to. It is the absolute value is important here. Absolute value m over absolute value f. But before we even get there, what am I saying? All right, we got ma, we got moment about point A. Is just gonna be 10 times 12. It's just 10 times 12. That's the distance, and the multiplied by the magnitude of the force, and then same with mb.
So is this your moment about A or moment like of the force acting on A?
That's gonna be about. It's gonna be about it.
Wait. I think that. Wait.
Well, no. So it's from our point. It's gonna be from. Yeah. It's gonna be from our point.
It's B.
Yeah,
right?
yeah. I
Acting-
used the distance between A and B for this one, and then for MB, we're gonna use the distance from B to C. So this distance.
Yeah. So you chose to do the moment calculation about B.
This is like M1
Because-
and M2.
Yeah.
But like
Okay,
using
yeah.
A and
Because when we're doing this magnitude, this isn't a cross product, so our force has to be perpendicular to the distance or the line of not the line of action. Is that the line of action? Is that
so you
what you
chose
call
B
that?
so that you didn't have to worry about like.
Yeah. We
that
didn't want
force.
to mess with that
So
angle thing.
could you do this problem if you did it about A? So you did about B, but you did it. Could you do it if I wanted to do it about A or about C?
I think you could. Yeah, it would just be a lot harder on yourself.
Okay.
You should do this. Or do whatever makes sense in your head. That is good. That's good. Good thought.
Yeah,
I like
as long as you be consistent, I think is the key
That's right.
with your positives and negatives and whatever.
So yeah, we rearranged, we got that. So now we're gonna solve for our ry, our x. So we have I'm sorry, I'm getting ahead of myself. I'm so excited. We have the net moment we need to solve for first. We're gonna use that in this equation here. So we have the given moment, 85, and then we have, this is positive 120, and this is gonna be negative. Negative 320 because it is, if we're, yeah, we're going clockwise for this one. So that's gonna be negative.
So you said counterclockwise
yeah,
is positive.
Yeah, I should have written
as
that.
is commonly instructed.
Yes. I think that's what we use in class generally.
Yeah.
Okay.
So this will give us negative 115 pounds. Now we're going to put it into our equation here. I'm so sorry. This is a typo. Okay. So our magnitude, our net moment, we're going to put that as our m in our numerator. And then in our denominator, we're going to use these forces we derived earlier.
Do you want a new marker?
So for ry, we have, we're going to use our fx, and for our rx, we're going to use our fy.
Why is that?
So that threw me off at first too.
Yeah, I was confused because I kept just trying to find the moment, and it was like, I was like, okay, where am I getting two values from? Like, what's going on?
No, that's a great question. It's from when we do moment, when we calculate for moment, as we kind of talking about down here, the force has to come in perpendicularly to the, especially when we're doing the magnitude equation, it has to come in perpendicularly to this distance or this line, and so for Rx, we need this Fy because it's coming in at a.
So for Rx, your y component is going to be perpendicular to the x-axis, and then vice versa for
f of x and ry. Yeah. And then we just plug in our numbers, and we get that. So we'll get these numbers, and then the question was also asking below, above B, or left or right of B, and we'll just we know that from the science of the answer we solved for.
Which I think is another reason why it's best for this question. Like, you could do the moment about A or C, but it's best to do it about B because the next part of the question is asking...
in relation
in relation to B. So you could do it with A. I don't even know how you would convert the... But yeah, I think that makes more sense, yeah.
Yeah.
Thank you, Thomas.
Yeah.
All right. Number 5. Okay, so this problem we're given a whole system. I don't know what this is, like a pipe system. We have 4 different forces which are each in line with an axis. And so the first part of this question is just asking the net forces. So it's pretty straightforward. All you're just going to take is add the XYZ components of each of these. So each of them is already in a singular XYZ. So it's just going to be, I think this is a typo. These should be the same. This should be. Wait, can I get a marker? Thank you. Okay, so you're just going to take each component, and then so it's going to be 300 and then negative. I should label my axes as well. Pretty straightforward, just negative 300 in the x direction, and then you're going to take the difference of these, and it's going to be positive 25 in the z direction, and then negative 240 in the y direction. So that's the first part of the question. And the second part of the question is asking about the moment calculation. So it's going to be kind of the same thing. You're just going to take each direction and do r cross f right here, our known and beloved equation. So I just have a sample one right here because I didn't want to write all 3 of them. But this is just the cross product of r and f. This is specifically for what direction is this for? What did I do? Oh, this is just for the, right here. This is just for the y direction. So you can see our distance right here is, so this, my bad, I said it wrong. This is the z direction. So we're using this 125 vector. So that's going in the negative z direction, seen right here. So this is the F component. It's pretty straightforward how to derive that. It's just looking at it. And then for our r, we're just looking at the perpendicular distance. So that's going to be, this is a little bit below the xz plane. So that's going to be a total of 120 millimeters. So then once you have all of those, you can just add them all up, and you'll get your total moment. But that's about it.
Is there a reason you did it about A? Could you have done another point? Or
I think it asked for it about A.
Oh, did it? Okay,
Yeah. I mean, yeah, I guess you could, but that would be interesting calculation.
Oh, so you did it in millimeters first, and then you converted out.
Yeah, I think for me it's just easier to convert to millimeters.
Okay. Like later on.
Yeah, later on. So I don't have to do I can only do one conversion versus
Okay.
doing like 20.
That's smart.
Yeah.
But for newtons, we do need to convert to meters at some point. Is that how that?
Yeah, I mean you
Oh.
should. Yeah, it should just be an
they
SI
want
typically.
meters.
But this right here is in Newton millimeters, and then this is just
because you
newtons.
just-
So yeah.
Okay. Nice
There
job.
you go. All right. Thank you for watching.
Thank you.
Adios.